Hello and welcome. My name is Satpit Singh and today we will discuss statistical analysis in research. The agenda for the presentation will revolve around statistical analysis, dwelling into its significance within research context. We will explore the crucial role of hypothesis testing, which provides a structured approach for evaluating hypotheses and drawing meaningful conclusions from data. Understanding descriptive and inferential statistics will be emphasized as they form the foundation for interpreting and drawing inferences from datasets. Additionally, I will discuss using various statistical tests to facilitate informed decision-making processes. A statistical summary of the provided dataset will be presented, followed by detailed analysis including t-test and one-way analysis of variance. I will address the absence of post hoc analysis and its implications. The correlation analysis will be discussed to understand the relationship between variables. The importance of statistical thinking in both research and workplace setting will be analyzed, aiming to foster a mindset conducive to rigorous analysis and interpretation. Finally, I will conclude with a summary of the key points discussed. Statistical analysis is a crucial component of research that involves collecting, interpreting, and drawing conclusions from data. It provides researchers with the tool to analyze patterns, relationships, and trends within their data, allowing them to make informed decisions and draw meaningful conclusions. Some key aspects related to statistical analysis in research are descriptive statistics that are used to summarize and describe the main features of a dataset. Measures such as mean, median, mode, range, and standard deviations provide a concise overview of the data. Inferential statistics involves making inferences or predictions about a population based on a sample of data. This is particularly important when it is not feasible to study an entire population and researchers need to draw conclusions from the representative samples. Hypothesis testing is a fundamental aspect of statistics analysis. Researchers formulate hypotheses about the relationship between variables, and statistical tests are used to determine if there is enough evidence to reject or fail to reject a null hypothesis. Hypothesis testing is vital in research as it provides a structured method for assessing the validity of a hypothesis and drawing meaningful conclusions from data. By establishing clear null and alternative hypotheses and applying statistical tests, researchers objectively evaluate the evidence in favor or against their assertions. This process enables confident decision-making, determining whether observed effects are statistically significant and not merely due to chance. Significance level, often set at 0.05, guide researchers in interpreting results with a balance between avoiding type 1 error, also called false positives, and type 2 error, also called false negatives. Through hypothesis testing, researchers contribute to the credibility and reliability of scientific knowledge, fostering a rigorous and systematic approach to inquiry across diverse fields. Statistics are employed in hypothesis testing to rigorously analyze data and derive meaningful insights. Researchers use statistical tools and techniques to assess the probability of observed results occurring by chance. By calculating p-value and comparing them to predetermined significance level, statisticians determine the strength of evidence against the null hypothesis. The choice of appropriate statistical tests, such as t-test or ANOVA analysis of variance, depends on the nature of the data and research question. These analyses enable researchers to make informed decisions about the validity of their hypothesis, ensuring robust and reliable conclusions. Through statistical methods, researchers quantify uncertainty, identify patterns, and generalize findings to broaden populations. Overall, statistics plays a pivotal role in hypothesis testing, providing a quantitative foundation for drawing scientifically sound inferences from collected data. The provided data represents statistics pertaining to sample group consisting of 504 individuals. Variables include subject number, gender, age, education, personality, job satisfaction, engagement, trust in leader, motivation, and intent to quit job. All variables have completed data except for trust in leader with 6 missing values. Mean value for the variables are subject number 252.50, gender 1.39, age 37.79, education 2.07, personality 5.19, job satisfaction 5.88, engagement 4.62, trust in leader 3.97, motivation 4.42, and intent to quit job 3.36. Median value generally align closely with the means. Mod value represents the most frequent occurrences within each variable, with multiple modes noted for some variables. Standard deviation measures the dispersion of values from the mean, with wider deviations observed in subject numbers, age, personality, and motivation. Range indicates the span between the maximum and minimum value within each variable. When graphically representing data, it is essential to choose appropriate visualization method based on the nature of variables. For scale variables like age and code, histogram with the normal distribution best illustrates the data distribution. Conversely, for nominal measures like gender and education, histograms suffice a graphical representation. Variables such as personality, satisfaction, engagement, trust, motivation, and quit falls under the ordinal measures. For these, pie charts and bar charts effectively depicts relative proportions or frequencies. For instance, mean and standard deviation are stable for scale variables like subject number and age, while mean and percentage of some are more applicable for ordinal measures. By selecting the right graphical representation corresponding to the measurement scale of the variables, we can ensure clear and accurate communication of the dataset's insights. To conduct a t-test, we use variables that represent two independent groups. In the given dataset, gender serves as the grouping variable with two categories, female and male. The other variables such as job satisfaction, intent to quit job, personality, engagement, trust in leader, motivation, and education represents the outcome variables that compare mean between the two gender groups. Null hypothesis states that there is no significant difference in mean between the female and male groups for each outcome variable. On the other hand, the alternative hypothesis suggests that there is a significant difference in mean between the female and male groups for each outcome. I choose significance level of 0.05, which is commonly used in hypothesis testing. This signifies that I am willing to accept 5% of chance of incorrectly rejecting the null hypothesis. After performing the t-test, I evaluate the p-value associated with the t-test statistics for each outcome variable and compare it with significance level. If the p-value is less than the significance level, I need to reject the null hypothesis and conclude that there is no significant difference in mean between the female and male groups for that variable. On the other hand, if the p-value is greater than or equal to the significance level, I will fail to reject the null hypothesis. To perform a one-way analysis of variance ANOVA, we need a categorical variable with at least three groups. In the dataset, trust in leader has two variables and education seems to have category variable with three groups. The null hypothesis states that there is no significant difference in mean trust in leader scores among the groups. On the other hand, the alternative hypothesis states that there is a significant difference in mean trust in leader score among the groups. I have chosen a significance level of 0.05, which is commonly used in hypothesis testing. This indicates that I am willing to accept 5% of chance of incorrectly rejecting the null hypothesis. Based on the ANOVA results, analysis of variance results, I compare the p-value associated with the F statistic to the null significance level, where the p-value is less than significance level. I reject the null hypothesis and conclude that there is a significant difference in the mean trust in leader score among the groups. On the other side, where the p-value is greater than or equal to the significance level, I fail to reject the null hypothesis. In this case, with the p-value of 0.945, I fail to reject the null hypothesis and conclude that at the chosen significance level of 0.05, there is no significant difference in mean trust in leader scores among the groups. In the given dataset, the variable education is categorical variable that has 7 groups representing different education levels. I have formulated two hypotheses, the null hypothesis and alternative hypothesis. The null hypothesis states that there is no significant difference in mean education score among the groups, while the alternative hypothesis suggests that there is a significant difference in mean education score among the groups. To proceed with hypothesis testing, I have chosen the significant level of 0.05, which is commonly used in hypothesis testing as we discussed before. This means that I am willing to accept 5% chance of incorrectly rejecting the null hypothesis. After conducting the ANOVA test, analysis of variance test, I compared the p-value associated with the F statistic to the significant level of 0.05, where when I found the p-value was less than significant level, I rejected the null hypothesis and concluded that there was a significant difference in mean education score among the groups. On the other hand, where I found the p-value is greater than or equal to the significance level, I failed to reject the null hypothesis. In the present scenario, the calculated p-value is 0.556. Since this value is greater than the chosen significance level of 0.05 value, I fail to reject the null hypothesis and conclude that there is no significant difference in mean education score among the groups. In the case of trust in leader variable, I did not perform a post hoc analysis because the one-way ANOVA analysis of variance did not result in a significant difference among the groups. The calculated p-value of 0.945 exceeded the chosen significance level of 0.05, indicating no significant difference in mean trust in leader score among the groups. Therefore, there was no need to conduct post hoc tests to investigate specific pairwise differences. However, for the education variable, I also did not perform a post hoc analysis because the one-way ANOVA analysis of variance did not yield a significant result. The obtained p-value of 0.556 was greater than the selected significance level of 0.05, suggesting no significant difference in mean education score among the groups. Consequently, conducting post hoc tests to explore pairwise differences was deemed unnecessary in this context. In both cases, since the ANOVA did not detect significant differences among the groups, conducting a post hoc analysis would not provide additional meaningful insights. Variables appropriate for conducting a correlation analysis for the provided datasets are job satisfaction, engagement, and motivation. These variables measure psychological constructs and are likely to be interrelated in the workplace context. Null hypothesis states that there is no significant correlation between job satisfaction and engagement. Alternative hypothesis states that there is a significant correlation between job satisfaction and engagement. Also, the null hypothesis states that there is no significant correlation between job satisfaction and motivation. Alternative hypothesis states that there is a significant correlation between job satisfaction and motivation. Additionally, null hypothesis states that there is no significant correlation between engagement and motivation. On the other hand, alternative hypothesis states that there is a significant correlation between engagement and motivation. Using a significance level of 0.01 commonly used in correlation analysis, I conducted Pearson correlation test between the variables. The results indicate that significant positive correlation between job satisfaction and engagement of 0.412 and p-value is less than 0.001. Job satisfaction and motivation is 0.543 and p-value is less than 0.001. And engagement and motivation is 0.511 and p-value is less than 0.001. The confidence interval further supports the finding with the lower bounds of the interval being well above zero for all correlations, indicating statistical significance. Therefore, I reject the null hypothesis and conclude that there are significant positive correlation between job satisfaction, engagement, and motivation among the sample population. These results suggest that higher level of job satisfaction tends to be associated with higher level of engagement and motivation in workplace, consistent with theoretical expectations. Developing a statistical mindset and cultivating statistical confidence are indispensable skills for any researchers or professionals working with data. I have recognized the importance of understanding statistical concepts, conducting rigorous analysis, and interpreting results accurately. Building a statistical mind involves embracing curiosity, critical thinking, and willingness to explore data-driven approaches to problem solving. It requires a deep understanding of statistical methods, their assumptions, and their limitations. I have gained a greater appreciation for the role of statistics in extracting meaningful insights for complex datasets. Statistical confidence is nurtured through practice, experience, and continuous learning. It involves trusting in one's ability to apply statistical techniques effectively, drawing valid conclusions from data, and engaging in hands-on exercises. Moving forward, I plan to implement statistical mindset and confidence in both my research area and my workplace. In my research, I will apply statistical method to analyze data, test a hypothesis, and draw evidence-based conclusions. I will strive to ensure transparency and reproducibility in my analysis, adhering to best practice in statistical reporting. In my workplace, I will advocate for the use of data-driven decision-making processes and encourage colleagues to embrace statistical thinking. I will offer guidance and support in conducting analysis, interpreting results, and effectively communicating findings to stakeholders. By fostering a culture that values statistical literacy and rigor, I aim to contribute to informed decision-making and drive positive outcomes in my professional endeavors. The statistical tests employed, including descriptive statistics, t-test, analysis of variance, and correlation analysis, have provided valuable insights into the relationship between differences within the datasets. Descriptive statistics allowed for a comprehensive understanding of the characteristics of variable under study, providing a clear overview of the data distributions. The t-test enabled the comparison of mean between two groups, offering valuable information about potential differences in various factors such as gender and education. Analysis of variation extends the comparison to multiple groups, allowing the exploration of differences across different levels of categorical variables like education. These tests are crucial in identifying significant variations and understanding the impact of different factors on the variables of interest. Correlation analysis facilitating the exploration of relationship between continuous variables, revealing significant positive correlation between job satisfaction, engagement, and motivation. The finding provides insights on the interconnectedness of these variables in the workplace context. For further details, kindly refer to the provided references. It contains additional information pertinent to this topic. Thank you for your time and attention during the presentation. Thank you.